Okay, so we have a setup here to test the operation of System Nicola Mk2. I have an oscilloscope here which also can act as a signal generator. I've set it up to generate an 88 kHz signal coming out here. I'll just turn this on. So immediately it's on receive, I'll power up the set and we'll start hearing the 1 kHz from the handset. I've got the volume turned down because it's a bit tiring otherwise. So the signal is actually being fed in through a pair of resistors to attenuate and so give a constant signal rather than just putting a piece of wire near it. We've got a fixed signal. If we look on what we're getting on the oscilloscope, so there, this is on 1 volt division, so we've got about 2 volts peak being provided by the generator, 10 microseconds division, so that's about 11 microseconds period, which corresponds to 88 kilohertz. We can test that. The meter here is working as a frequency meter. We have 88 kilohertz, and so we're hearing about 1 kilohertz. So to explain the circuitry a little bit, this is oriented so that the multi-way connector is on this side, which connects to the rest of the set. The signal from the antenna comes in through here. This is a protection varistor to protect against overvoltage. It comes through some filtering, T filters to filter out high frequencies, some power supply chips, and then comes through a tuned circuit here to concentrate the signal at around 88 kilohertz. That's an LC circuit there, and then comes into the mixer. So this, the AD607, does the work of the radio set. It actually consists of 2 mixers, one to up-convert the signal coming in and go through the IF filter. In fact, there are 2 IF filters, one here, a ceramic filter, and one the other side of the circuit board just here as well. Now, it's the same set of mixers which are used for transmission and reception, and it's this chip here which does the switching. It takes in fact, 3 signals. 2 signals are the 2 local oscillators, one to do the up conversion, one to do the down conversion, and those frequencies, depending on whether receive or transmit, swap round so that when receiving the 88 kilohertz it adds, I think it's 533 kilohertz. We can measure that here. Over. So yes, sorry, 544 kilohertz roughly, and the other local oscillator we can measure here is in fact just above 455 kilohertz, so that when it adds to the audio frequency it's in the 455 kilohertz to select only the upper sideband. You can look at those on the oscilloscope, and we'll take a ground from here. That's one side of the filter, and if we measure here, look on the oscilloscope, and that's our 544 kilohertz. If we look at the other one, measuring there, okay, on the oscilloscope, let's adjust the trigger, or let's turn up the scale. So now we're at 200 millivolts division, and that's our 457 kilohertz. Okay, so the function of this chip is to swap those 2 local oscillators depending on whether we're on transmission or reception. But if we look just here, for example, we look on the oscilloscope, turn this down. As we press the button, then we'll see it switches at that point the signal from one frequency to the other. If you measure the frequency at that point, you'll see it switch. And the other local oscillator presented to the mixer, we can see here, Okay, and again that will be the other way round. As we press on transmit, it goes to that, and released, it goes back to that. Okay. So far so good. So those are the local oscillators going to the mixer chip, and similarly this switch switches either the audio from the microphone or the RF signal from the antenna to the mixer chip, depending on whether we're on receive or transmit. Currently we're on receive, and we're feeding the 88 kilohertz, and so if we look at the first filter, so this is after the first mixer, we should see a 5 kilohertz signal. Measure, look on there. It'll be quite small, so we'll need to turn up the gain. Let's go to 1 microsecond division, just the trigger. There we go. So that's just over a 2 microsecond period. That's our 455 kilohertz signal. If I disconnect the input, you'll see it disappear. And reconnect. So that's proving that that's a signal coming from the input. Okay, now we can then trace that through the circuit. So that's come after the first mixer, 88 kilohertz, being mixed with a 544 kilohertz and generating 88 kilohertz. After that it will go through an IF gain with automatic gain control, and then come to the second filter, which is just here. If we measure this point here, we get a much bigger signal. Look at the oscilloscope. So now we have to turn the gain. Whoops. Have I got it? Just missed it. There we go. I turned down the gain, so now we're back to 100 millivolts division. We've got a good solid signal, still at 455 kilohertz. Again, if I remove the input connection, look at the oscilloscope, it will immediately disappear, but then it will start coming up again because the automatic gain will search on the noise that's coming through. Okay, so it comes up a little bit. But essentially, if I disconnect the input signal, the 88 kilohertz disappears, and when I reconnect it, it's there, so all's looking good on reception. So that's after the IF gain stage. Then it will go through the second mixer, and that should then convert it down to the baseband, and will come through onto this chip. This is the U1, and we should see the signal on both pin 1 and on pin 7. We can put it on pin 1, which I think is also this resistor. Hang on, I'll just have a look. So pin 1 actually goes to this resistor as well. And we look on the oscilloscope. Look on the oscilloscope. And we need to turn the time base down because this is an audio signal. We'll turn down the sensitivity. So now at 1 volt division. We're actually putting in quite a big signal. You wouldn't expect to get such a big signal with a real antenna, so that's why we're starting to see clipping. But anyway, we're seeing, if we turn down to 1 millisecond division, we're seeing our 1 kilohertz signal as expected. Again, if I remove the input, we'll see it disappear. So that's certainly coming from the input. So receive looks to be going well. We'll now look at the transmission. So go back to the first filter, and we'll have to turn up the sensitivity again on the oscilloscope, and the time base back to, let's say, 1 microsecond division, and we're seeing our 455 kilohertz gain. I'll actually disconnect the input so that's gone to 0. Disconnected, and now we're going to look at the transmission when I put a signal into the microphone. So I think we'll need a bit more gain because this will appear a lot smaller. So I'll turn the gain up now This is essentially 1 millivolt division, so I need a fair bit of gain. And what I'm going to do is I'm going to take the microphone and I'll just whistle into it and see if you can see something. So first press the PTT. Okay, so the signal is modulating nicely as we send the audio signal in. Now we can check again after the IF gain stage. So that's at this point here. This is actually the input of the second filter. We'll need to turn the sensitivity down a lot because we're going to get a lot more signal here. And there'll be some automatic gain function going on as well. So I'll do the same, press on to transmit. Now you'll see the automatic gain does give some signal even when I'm not talking into it. That's because it's trying to pick up something. But certainly when I whistle, the signal gets bigger, and so that all looks good. So if we get back to the circuit, we do the same thing looking at pin 1, which we decided was actually connected to this point here, pin 1 of U1. If you look at the oscilloscope again, now we should get a signal round about 88 kHz when I whistle into the microphone. So put the time base onto 10 microseconds division now. And now try again. Okay, we'll turn the sensitivity down. We're now at 2 volts division. So we're there seeing our 88 kHz signal. We're at 10 microseconds division, so that's again as expected, and that should go out to the amplifier. So that's showing that the mixer is working correctly, doing the up conversion and down conversion for both reception and transmission. Okay, hope that helps.